You're up, and you're going to be talking. This is Daniel Young, Senior Manager at Toshiba America. And we're talking. Is this the right Is this the right name? MetalSpector. You muted. Can't hear you.
Now.
Nah, there you go.
Okay.
Is that the name MetalSpector?
MetalSpector, yes.
Sounds. You know what it sounds like? It smells so James Bondish. You can run with that. All right, the floor is yours.
All right. Well, hello. Thanks everyone to joining. Again, my name is Daniel Young. I work with Toshiba America. This case study is actually coming out of Japan, so but it's a good customer case study. This was published in the November 2021 edition of the IIC's Journal of Innovation. I think Eddie is involved in that, so please check that out. I'm sure someone from IIC might actually pop that in a link in the chat window. But I want to show how digital transformation within Toshiba is changing our focus internally, helping us really shift from primarily, a hardware service provider, custom integrator, over to a user-focused services provider. And I think that dovetails well with what Bassam and Eddie have already talked about. So to get started, let's look at the steel industry for a moment and specifically look at some key concerns they have in their quality inspection process. So this is a very basic diagram here, but it shows a quality assurance station on a steel production line. So the samples of this outgoing steel, they're inspected, judged by a QA inspector under a microscope. The term is metallography. These inspectors, they're performing this measurement grading process based on established steel industry standards, in addition to their own quality assurance specifications. In Japan, it's mostly coming from JIS, which is the Japan Industrial Standards. In the US, we would use the American Society for Testing and Materials, ASTM, but they're both equivalent. JIS 555 is the methodology in Japan, and in the US it would be ASTM E45, but they also use that pretty much universally. Other areas of the world will have their own standards. Now, Toshiba has been selling MetalSpector, this system, for a very long time, I think a couple of decades even. And it's specifically designed to help test and measure for what's called non-metallic inclusions in metal samples. So any voids in the sample of metal as it's being produced, any voids that don't have metal in them are non-metallic inclusions, and you want to minimize those depending on how strong the steel needs to be. And this system, it's basically, it's an auto-focusing optical microscope. You have an XY stage, which you place the sample on and move it. There's a color camera, hardware image processing, PC, that kind of thing. It's a hardware system, and it requires hardware upgrades periodically, for improvements. So you place the sample on this XY stage, you move it into position, autofocus the microscope, the camera records the image, and the image processing software provides you a screen as we see, and then the inspector can perform their measurement. And this has been the system for quite a while, right? Improvements to hardware, but not much else. So there was a very strong awareness that even with this system, and it's the improvements over time with this system have mainly in the image processing and the autofocusing. So it's a process that takes on the order of minutes. So if you can shave a minute off, that's a huge improvement. Sometimes in manufacturing, depending on the manufacturing process, you may think in terms of seconds, and this is a case where we're thinking in terms of minutes. So there was a strong awareness that it's difficult to standardize and automate this visual inspection, mainly because the QA inspectors are still performing this and making the judgment grade based on these existing standards from JIS, ASTM, and user specifications. So inspector judgment is very crucial. Veteran inspectors are very important to have. Training these new inspectors takes a long time, so you have to have the workforce. You have to have a pool of workers that not only can be trained but have the time to become veterans. So Toshiba's again been working closely with this customer for quite a while. So we've identified here 4 major issues, pain points. Number one is this is a very labor-intensive QA process. Of course, it's on the order of minutes, and because this grading process requires human inspectors to grade each sample, the grading process quickly becomes the largest bottleneck in the manufacturing process, especially if you have a low number of inspectors or qualified inspectors. Number 2, long inspection hours. The steel inspection is sampled per the amount of steel, not by a set number of samples per day. So as more steel gets produced, more samples are required to be graded. So you've got longer hours for these human inspectors. That leads to a lack of consistency. As these inspectors are asked to work longer hours, they get fatigued. And it becomes increasingly difficult to maintain a level of consistency in this grading process, even if you add more inspectors. So the last one is the red flag. The worst of all is data fraud. As the demand for more output increases, there's intense pressure to actually falsify records, report gradings that are not correct, just to meet the demand for steel production. Now, in recent years, it's become public that several steel manufacturers around the world have falsified records. I know one in the U.S. Earlier this year. I think there was a conviction on that. So this is a worldwide problem. There are problems. Oh, could someone please mute? I'm getting an echo. Oh, thanks. So the worst of all with this is you've got bad quality product. You've got regulatory fines when these companies are caught, and they have been caught. There's litigation, and there's ultimately terrible damage to the company reputation. A couple of other items of note here that lead into the customer requirements is, currently the inspection work records were not being automated, so there was room for human intervention, creating the opportunity for fraud. And the other is the retirement of veteran inspectors, aging workforce issues. So you really have to train new workers and get them up to speed very quickly. So the major customer requirements here are to reduce the inspector workloads and provide some type of automated auditing capability. So with that, I'm going to switch over to Toshiba, what we've been doing, what's been underway for a while. So we're in this major strategic corporate shift. So we're transforming primarily from a hardware sales business to a services subscription business, namely in infrastructure services. So it's not that Toshiba is going to stop selling hardware and systems and installations and all that. It's just that we're pivoting to offering more operations and maintenance services under a subscription model. So in the future, we plan this infrastructure targeted for services to leverage data, increase convenience, and value add to customers. These managed services will be enabled by technologies like advanced algorithms and machine learning, AI, as we've seen, vision and image processing, as we'll talk about in a minute, cloud computing, data management policies. So this is a major step forward for us at the corporate level to become an infrastructure services company that takes full advantage of cyber physical systems. Now, the approach that we're taking on this is what we call a meet in the middle, which just means that we take our technology, core technology from the bottom and the business needs from the top, and we meet somewhere in the middle with that with the customer. And this is similar if you look at the IIRA, they have these structured viewpoints Business is at the top, kind of the most important, right? And then implementation is down at the bottom, also important. So I talked about our business strategy, and our technology strategy is based on what we call TIRA, which is the Toshiba IoT reference architecture, and it's based off of the IIRA from the IIC. And this is going to guide our technical redesign that we'll get to in a minute. Now, moving back to the steel industry customer, we're making several observations here, and these are in this potential solutions. Process automation. Now, this inspection process part of it can be automated, but it's not right for complete automation. It does require human judgment, and we'll talk more about that eventually, but regulatory issues standards still require human inspection of these metal samples. However, a lot of this initial setup work, setting up the sample, focusing, taking the image, recording it, that can certainly be automated. So that's taking away a lot of rote work, if you will, from the inspector. The second set of automation is on the measuring part. So the steel industry is looking at AI-based measurement standards, and these are statistical methods. They're called clean steel measurements, if you've ever heard of that. It's currently underway. We're not there yet. There's still regulatory issues. There's still standards being worked on and developed, and of course Toshiba is a part of that process. But the system should be designed to be able to take advantage of those enhancements as they come along and as the industry matures. But this doesn't eliminate the quality tester ultimately. In fact, the need for veteran inspectors is very high, even if these statistical methods were able to be used. Next up is hardware-based improvements, and this is kind of Toshiba's old way of thinking, if you will. So in the past, major updates to MetalSpector were hardware upgrades, a new microscope, new cameras, a new image processing card, new PCs, faster PCs, more memory, faster, bigger, everything. But today, we realize that the hardware is largely commoditized. It's reached kind of a point of diminished returns, and this is, thanks to progress in PC processing and industry standards. But nowadays, the advancements in the image processing speed comes from the software algorithms themselves. So it kind of think of it as the Pareto principle, 80-20 rule. You might get a 20% improvement with hardware upgrade, but you get 80% improvement with a new software algorithm. So which would you rather do, right? Finally, we have cloud-based tools. Now, using cloud tools in an industrial setting requires a lot of things. I think Accenture's talked to some of those issues with cloud, but it's a lot different in an industrial setting. The primary point I want to make here is that it requires customer business agreements. You need to be clear and upfront about what you're doing, what data you're collecting, what you're going to do with it, and that. So Toshiba's been a partner with this particular customer for a long time, so we already had a level of trustworthiness already, and this will become more important later on. But the point is to be very upfront about the use of the cloud. So with all this in mind, we've got the customer requirements, we've got our own corporate transformation going on. So this latest version of MetalSpector was designed with the customer pain points and requirements in mind. And those were, two basic requirements: reduce inspector workloads and provide automated auditing capabilities. So Toshiba designed this new system to take advantage of the existing hardware because it didn't really need to be updated, or the customer can do those updates themselves, but use an industrial IoT architecture on top of it. So again, using TIRA, the Toshiba IoT reference architecture, which itself is an example of the 3-tier architecture pattern from the IIRA. So now let's blow this slide up and go into a lot more detail. So I'm going to walk through the system process briefly, and this is a busy slide, but it's it still doesn't include everything. But first, we'll walk through it. So number one is we transfer the steel samples image data from the microscope to a historian database. And that uses the same equipment as before, no need to change the hardware. And also the original process remains very similar for the inspector. So training the inspector for this new system is not a major issue. So we transfer the image data with a sequence number to the cloud. I'm going to show that going across here. And this is feeding the AI model estimator. So by automatically recording these image samples, we establish an audit trail, and it doesn't require any additional workload for the inspector. Again, a positive. Next is we're storing the steel grade estimate from the AI model. So we go through the AI process, and we sequence it back on the customer side, on the edge, into their log database management system. So that logging is on the customer side, not in the cloud. Now, next up is inspectors do their job, right? They determine the final quality decision. They refer to the estimated steel grade estimate because it may have, it can look at maybe easy samples, right, that it already knows about. But by automating that image recording and AI estimation, the inspector can concentrate on the steel grading process. So the estimation engine may aid the inspector, by identifying some routine inclusion patterns. And this allows the inspector more time to look at the more difficult ones. Now, what I don't show here in this diagram is that information is actually fed back to the AI model, because that is also part of the training process. So after the inspector makes their grading evaluation, that gets taken back to the AI model and used to improve it. So a couple of things to note here. Because we're using a cloud service, we need customer permission to access their data to perform the AI analysis and to record and log it for the audit trail. Now, we talked about this before, but this was, again, well understood in advance and discussed with the customer. The point being is that because we had a strong relationship with the customer already, a good level of trust was established, and this made that discussion of using cloud services a lot easier. Now, that's not always the case with every customer, especially new customers to industrial IoT services. Kind of a different set of issues than the data privacy rules, but very similar. What are you going to do with my data? How do you use it? How do you store it? How do you secure it? Those type of issues need to be discussed up front. I would actually encourage you to check out the IIC's Industrial AI Framework for more in-depth dive into that topic. There's also the Trustworthiness Framework that I believe was released late last year that talks about the trustworthiness concerns. But anyway, other point to note is this system, again, it's always in a state of training. The AI inference model here is always developing its own analysis skills as it runs. So it's getting new training data to feed the model. So each sample it receives, as well as the analysis of the inspector, improves the model. And the inspector doesn't have to do anything additional for this to happen. So no additional process or workload on the inspector for this. So needless to say, this new version of MetalSpector was very successful, met the customer requirements. They liked it. It's their white sheep story, as Bassam would say. But it opened up a new dialogue with the customer around inspector training, and this is kind of the real point of transformation for us. So we identified a new process issue. Well, not a new problem that not a new problem that we were considering initially, and the customer really didn't see this as a problem that we could necessarily solve. But this speaks again to the change in our culture about thinking about product functions versus product usage. So as we looked at how the customer was using this system, we realized that the veteran inspectors were also responsible for training the junior inspectors. And as I noted earlier, this is a very time-consuming process, and that just increases the overall value of these veteran inspectors. Now, veterans eventually retire, they move on, leave, so new training is always important. So we thought about how could we help with the skills transfer using this new system. So because the system was designed with the idea of service add-ons from the get-go, we realized that we had most of a training system already. So if we could just add a learning service onto this, we could provide a training system that could offload much of the work of the veteran inspector in that training process and give them, again, more time to do their grading inspections, which is their most important job. So of course, we did this with the support of the customer. We talked with them about it, went over it. This new service uses the same AI inference model that we already have, and it uses the same collected samples to teach these junior inspectors. And we measure the progress on the way. And because the inference model is also learning from the veteran inspectors and the real world samples, this training system is also always improving. So as new types of steel get produced, the AI model can be trained on these new alloys, and the trainers get it as well. So to wrap up here, we looked at this transformation from two different perspectives, Toshiba's as well as our customers. So from Toshiba's side, we have a mindset change, fundamentally changing from this, how the product is actually used by the customer over just how does it function and how do we make it faster. Revenue, we are changing again from this fixed purchase, non-recurring engineering costs to a subscription-based service. Solutions, again, this goes along with the mindset, but focused really on user-defined services. And then at our business level, this is a change from a custom installer, custom integration business to one of modular services that can not only be used with one customer, but we can adapt to other parts of our business. Now, on the customer perspective, we've got data integrity. We've got the eliminating sources for intentional human fraud. Workload efficiency, we're offloading work for these veteran inspectors so they can do their most primary job. Continuous improvement, always a good thing to have. This AI model, again, it improves over time, so it's always getting better. It's always adapting to new samples, maybe new materials that are being produced. And finally, the skills transfer, realizing that we have human inspectors that are valuable, and they need to be trained. They need to be trained as best as can be. So lastly, and I'll wrap up after this, just briefly talking about our technology and enablers. So we highlight 4 enablers here, and I think after hearing Bassam, maybe we could change some of these. He mentioned, the servitization DX enabler, which I think is appropriate here, changing products into services. But in addition, we have artificial intelligence. Obviously, this steel AI image sample has really improved things. Cloud computing, running things in the cloud is eliminating the need for hardware upgrades and downtime, associated downtime. There's still a level of resilience, however, because even if the service is shut down, say you lose internet, the process can still continue. The AI doesn't eliminate the use of the inspector; it just aids, right? Another big trend enabler is image recognition algorithms. Similar to the AI. AI are just algorithms, and the image recognition is also algorithms. It's software. So these get applied at the edge now, not on the cloud side, but because they work with commercial off-the-shelf hardware, that's a big improvement. And finally, data management. So providing this audit trail to ensure data integrity and eliminate, possibilities for human manipulation of it. And with that, I think that's it. Is a picture here of Toshiba Spinex website with our AI grade determination service. These are all microservices, so they can operate at the cloud, edge, on-prem, in multiple configurations. So I hope this has been informative for you. This example, at least from our side, has really shown us how we can transform IoT data into new business values. And that's especially important for us to validate, this customer story against our corporate strategy. It really shows how effective and powerful industrial IoT solutions can be. Thanks for your time. I'll hand things back over to you, Scott.
All right, we've got some questions. Thank you, Daniel. That was a good
Great.
conversation. I have some questions, but I'm not going to ask them. But I know Lee has a question here, and if you can answer them, you can answer them. If not, well, I can't. What is the status of CPS development in Japan today compared to the CPS development by the NIST?
Oh, interesting. I don't know that I can answer that in terms of Japan. I can say that in terms of Toshiba, we've actually tried to align very well with the with Nist's CPS framework, and that's the other half of the Toshiba reference architecture is using the IIRA from IIC, and then the Nist CPS framework. So we use that to drive our development strategy, and then applying that to sales and business transformation, I think is where we're at now. I don't know if that exactly answers that question, but I think there is an alignment effort, at least from our company.
Sounds like a plan. All right. This is from, and please, I'm going to do the best I can. Abhijit. Okay, I'm gonna flip his questions or her questions. I'm gonna say, and how do you add new process requirements by the customers?
How do we add new process requirements by the customer? So in this case, we were on site a lot, so we're actually observing, what's being done, how they're using this, how they're using these systems, and then trying to figure out, okay, how can we create a value add? So I think in the industrial setting, it's still requiring hands-on. You need to go visit the site and actually listen and see how they're using your product or service, and then listen to them. If they have other pain points, then you look at how you can address those.
And this was also by Abhijit. How do you onboard new customers? Given this example, it's sort of a broad question. What is your typical approach on onboarding customers?
It starts at the business discussion level. So we have, we may have a contact that asks a question if Toshiba can provide something, and we start that discussion. We see what their customer requirements are and what our services are, and if at the at the high level, at the business level, if they see that there's a possibility, then we might make a trip, physically meet, and discuss those plans.
Ann has a question again, and this is the one I would have. How much human review is still needed vis-a-vis the AI output decisions? Sometimes, AI speeds up the number of initial raw decisions that a serious workflow imbalance backlog is created for the human review. For example, this challenge in AI, text transformations. So, does that make sense?
How does the human deal
Yeah, how
with?
much human review is still needed vis-a-vis the AI? So you got that loop that goes in there, and you got this,
Yeah.
I'm a human and I got to still, but the AI is learning and always learning, and eventually, my question, along with dovetailing with Ann's, it would seem to me that there will be eventually no need for a human or very limited human interaction.
Right, and yeah, in this case, that is a process. The steel industry, they are looking at these clean steel measurements, and that's ongoing. And it could one day, that could be the issue. We could reach that state. There's still regulatory concerns, though. Regulatory bodies in Japan are currently saying no, we need a human inspector in that case. So I really see that as similar to was it in the oncology field where they had an AI process that was in some cases doing a better analysis in the medical field. But does the human trust that? So I think there's a lot of political and regulatory things that have to happen. But from our side, we can just keep making it better and improving on it. The other thing is that, yeah, the human inspector in this case is always necessary because no steel manufacturer wants a bunch of employees that have no idea how to make these measurements, right? That would not be good for a steel manufacturer. So they're going to value those veteran inspectors regardless. But maybe those inspectors can concentrate on more difficult, challenging things to do rather than some of the easier samples.
Yeah, that's true. And I'm not sure I see it. Dar's Wheel, Harriet, here it is. I'm interested in knowing what you are doing about user acceptance, right? You just sort of brushed upon it a little bit. We know that humans don't like change and will slow walk and possibly sabotage when organizations seek to change process without buy-in.
Yeah. I came originally from a manufacturing environment early in my career. I won't say how long ago that was, but I remember I made a piece of automated equipment, and I was training the inspector on it. And she asked me a question on how to do something, and I said, "Well, move the mouse over here and click that." Well, she physically picked up the mouse, moved it over on the mouse pad, and dropped it, and looked at me. And I was young, and she was older than me, and it really hit me in the head that I'm not speaking to her as a user of the service, right? So that's a great question, and it's always important to reduce the headache on the person using the system. So in this case, we really tried to minimize any changes to the environment. We don't want to add extra work to the inspector because they've already got enough work. We're trying to eliminate work from them. So trying to keep their process as similar as possible. And if they had headaches in that process, how can we remove it? So if we can automate, their initial setup procedure, that takes a lot of work off of them. So yeah, again, being on site is critical. Seeing how they're actually using the equipment is critical, and having that conversation of, hey, can we take this burden? Do you see this as a burden, and we might have a way of eliminating it?
Well, we have more questions. However, we're going to have to proceed forward to the next topic, and then we'll open it up, and I'll ask these questions during our panel discussion. So, Tom and Shohi, I hope I said that name right. Stay tuned, Lee. We're going to definitely ping you on that and add, of course. So we have continuous improvement, Kaizen-driven approach. Hajim, I hope I said that name. If not, correct me, please. And he's with Digital Manufacturing Chief Evangelist with Mitsubishi Electric. It's your floor right now.